Okay, regarding general pharmacology, it will be divided into two major groups. One is pharmacokinetics and another one is pharmacodynamics. Under pharmacokinetics, generally we study about four things about drugs. That means absorption, distribution, metabolism and excretion of the drug. How the drug gets moved inside our body, that is pharmacokinetics. The second one is pharmacodynamics. Under that, we will be studying about the actions of the drugs. What is its mechanism of action, pharmacological action and interactions, adverse drug reactions, like that actions we will study under pharmacodynamics. So, under pharmacokinetics, the second important topic is distribution. That means how these drugs gets distributed inside our body. After membrane transport, the drug goes inside our plasma. That unmetabolized drug gets distributed inside our body before going for metabolism. So, the study about this process is called as distribution. And what are the factors modifying distributions? So, these are the things we are going to see in the today's PowerPoint. Okay, what is for distribution? It's a branch of pharmacokinetics which deals the disbursement of an unmetabolized drug inside our body. So, after absorption, after membrane transport, what happens to the drug? That means how it gets distributed inside our drug. The drug reaches the systemic circulation after absorption and direct administration. Then it has to cross the capillary membrane to reach the interstitial fluids. First step is it has to reach, that is, it has to cross this capillary membrane to reach this interstitial fluids. Interstitial fluids are those which are outside the cell. That means outside the cell, the fluid present is called as interstitial fluids. So, after passing this interstitial fluid, it has to cross the cell membrane to reach inside the cell. Inside the cell will be this intracellular fluid will be present. So, after crossing this capillary membrane, it reaches the interstitial fluid, and after crossing the cellular membrane, it reaches inside the cell and gets mixed up with the intracellular fluid. So, the first step is after absorption or membrane transport, the drug has to cross the capillary membrane to reaches the interstitial fluids, and after that it has to cross the cellular membrane to reach the intracellular fluid. So, in our body, generally the measure of fluid present in our body is around 42 liters. So, if you divide that, mainly 14 liters consist of the extracellular fluid. That means the interstitial volume is 10 liters and the plasma volume is 4 liters. And then intracellular fluid, that consists the remaining 28 liters. So, 28 liters of intracellular volume and 14 liters of extracellular fluid, including interstitial fluid, is present. And this 14 liters is divided into plasma volume is 4 liters and interstitial volume is 10 liters. So, this is the where the drug gets distributed. And the next step in distribution is calculating apparent volume of distribution. The calculation of apparent volume of distribution is very important to understand the movement of the drug inside our body, to know the pharmacological actions and its adverse effects inside our body. So, what is this volume of distribution or apparent volume of distribution? That represents the entire amount of the drug distributed inside our body, and we are assuming that the amount present in plasma is equal to the amount which is present inside the entire fluid. That means in this 4 liters, how much drug is distributed? This is the amount we are going to see. We are assuming the same amount of drug is distributed throughout our body. So, throughout this 42 liters, we are assuming the same amount of drug is distribution like in plasma. So, we are calculating the volume of distribution. Because of that, we are adding the word apparent volume of distribution by using the formula dose of the drug given by intravenous route by concentration of the drug in plasma. So, the important thing is assuming it is distributed throughout the body at the same concentration as in the plasma. So, like in plasma, throughout the body throughout extracellular interstitial fluid, intracellular fluid, everywhere it is distributed in the same concentration, assuming that we are calculating this volume of distribution. So, the formula is dose of the drug given by intravenous route and concentration of the drug in plasma. Consider if a dose of a drug is 100 mg, we have given by intravenous route, and the plasma concentration when we are seeing it is 1 mg per L, that is 1 mg per liter. The volume of distribution, apparent volume of distribution is 100 liters. So, here the plasma concentration is very less, so the volume of distribution is very high. For example, for heparin-like drug, if you are giving 100 mg by intravenous route, the concentration of drug in plasma will be 25 milligram per liter, so that the volume of distribution will be 4 liters. So, the volume of distribution will be low or less when concentration in plasma is high. This is inversely proportional. This is apparent volume of distribution. The important thing is greater the Cp, that means concentration of drug in plasma, the volume of distribution will be low, vice versa. Why this point is important means we are going to study the factors which modify the distribution rate. So, while we are studying certain plasma protein binding means the concentration of the drug in plasma will be high, so that the volume of distribution will be low. If the concentration of the drug in plasma is very less, the volume of distribution will be high. So, according to the volume of distribution, the pharmacological action, adverse reactions of the drug as well as excretion of the drug will be taken care of. Therefore, follows that the factors that increase Cp will decrease as the volume of distribution. This gives an indication of the importance of knowledge relating to the drug's plasma concentration and the volume of